Given that M is the mass of a substance deposited in an electrolysis and Q the quantity of electricity consumed, then Faraday's law can be written as A. M equals to QZ, B. M is equals to Q over Z, C. M is equals to Z over 2Q, D. M is equals to Z over Q. Solution. According to the first law of Faraday, the mass of substance M deposited at the electrode is directly proportional to the quantity of electricity Q used up. Thus, Q is directly proportional to M, that is, M is equals to constant KQ, or Q is equals to Km, where M is a constant. Therefore, the answer is A. Question 83. Half of zinc of 2 valency ion plus it will discharge 1 electron to form half of zinc. In the reaction above, calculate the quantity of electricity required to discharge zinc. A. 48.200 times 10 raised to the power 4 coulombs. B. 9.650 times 10 raised to the power 4 coulombs. C. 4.820 times 10 raised to the power 4 coulombs. D. 0.965 times 10 raised to the power 4 coulombs. Giving Faraday to be equal to 96,500 coulomb per mole. Solution. In the reaction, half zinc of 2 valency electrons will gain 1 electron to give half zinc. Half mole of zinc ion was discharged by gain of 1 mole electrons, but 1 mole of electrons is transferred by 1 farad of electricity, or 96,500 coulombs. 96,500 coulombs is equal to 9.650 times 10 raised to the power 4. Therefore, the answer is B. Question 84. For a reaction in equilibrium, the species involved in the equilibrium constant expressions are A. Gaseous and solid species, B. Gaseous and dissolved species, C. Solid and dissolved species, D. Liquid and solid species. Solution. Equilibrium constant expresses the ratio of concentration of the products and the concentration of reactants raised to the power of their molar quantities. The species involved are usually solid and dissolved species. Example, silver chloride in a reverse reaction to give silver chloride, and in a reverse reaction, concentration of silver ion times concentration of chlorine ion all over the silver chloride. Therefore, the answer is C. Question 85. The substance often used for vulcanization of rubber is A. Chlorine, B. Hydrogen peroxide, C. Tetraoxosulfate 6 acid, D. Sulfur. Solution. Vulcanization is the process by which soft rubber is converted to tougher and more elastic material resistance to wearing out by heating the rubber with sulfur, which forms cross-link between the adjacent rubber molecules. Therefore, the answer is D. Question 86. 0.46 gram of ethanol when burned raised the temperature of 50 gram of water by 14.3 Kelvin. Calculate the heat of combustion of ethanol. A. Minus 3000 kJ per mole. B. Minus 300 kJ per mole. C. Plus 300 kJ per mole. D. 3000 kJ per mole. Given that carbon C is 12, oxygen is 16, hydrogen is 1, specific heat capacity of water is equals to 4.2 joule per gram per kilo per Kelvin. Solution: 0.46 gram of C2H5OH ethanol produces 14.3 Kelvin in 50 gram of H2O, given that the specific heat capacity of water is 4.2 joule per gram per Kelvin. The heat change, that is delta H, is equals to mass of HO times specific heat times rise in temperature, that is 50 for mass of water times specific heat, which is 4.2 times rise in temperature, which is 14.3, which gives us 3003 joules. 46.0 gram in bracket 1 mole of C2H5OH, which is equivalent to 3003 over 0.46 times 46 over 1, which gives us 300,300 joules, which is the same thing as minus 300,300 kilojoule per mole. For the answer is B. Question 87. The graph that describes a zero-order reaction is A, B, C, D. Solution: consider the reaction A plus B giving C plus D. The rate of disappearance of A is equal to minus the concentration of A over the T, and B minus the concentration of the B over the T, and the rate for the formation of C is equal to plus the concentration of C over the T. Rate of reaction can be represented graphically by plotting concentration of the product or reactant against time. Example: looking at the graph of concentration against time, we have the curve of concentration of D and the curve of concentration of C. So concentration of C is equals to the minus the concentration of C over the T. Concentration decreases with time, and concentration of D is equals to plus the concentration of the D over the T. Concentration increases with time when the rate of slope is independent of concentration. It is described as zero order. That is, when the slope is constant at any point with increase in time, it is zero order. Therefore, the answer is B.